guys, welcome back to Chemistry 24 into 7. In this series, we have been exploring solution to previous year's competitive exam papers. If you are new to this channel, don't forget to subscribe and hit the bell icon for notification. Today, we are going to tackle a problem based on several concepts such as LDA, the formation of Silyl ketene acetal, and 3,3 sigmatropic rearrangement and Ireland glacial rearrangement. Let's dive right in and solve this together. Let's start by looking at the today's problem, which is from the University of Hyderabad PhD 2018 entrance exam. So the question provides us this substrate initially react with LDA and followed by trimethyl silyl chloride that produce this product X. This product X further converted into product Y under heating reaction condition. So here you see there are the four options for X and Y. Let's find out together which is correct option for this question. Let's start with our first reaction condition is LDA. So first let's review about the role of LDA. So LDA is non-nucleophilic sterically hindered strong base that readily abstract a proton from acidic position. We have discussed the LDA before, but if you missed that video, don't worry. You can find the link in the description box below. So LDA is particularly useful for generation of enolate ion by deprotonating less hindered side of the substrate. It can also abstract a proton from benzoic oxygen and even acidic aromatic protons also. So let's come to the our substrate. When you use LDA that readily abstract the proton from this position, but here one problem. What enolate you will get? Either E-enolate or Z-enolate. We already know that the formation of enolate ion undergoes by cyclic six-membered transition state. So now you consider this example. So X means some substance as well as R also some substance. So when you use lithium diisopropyl amide like bases, which readily undergo by cyclic six-membered transition state, resulting that produce corresponding enolate ion. So here you see there are two type of cyclic six-membered chair-like transition state would be possible. So first you look this first transition state. If you have your substrate larger R group as well as large L group that may feel 1,3 dioxyl interaction. If you have larger 1,3 dioxyl interaction, this transition state readily switches into this transition state. However, this transition state also encounter allelic 1,2 strain. So that means that if you have larger X group that encounter the allelic 1,2 strain. So if you have larger allelic 1,2 strain, so this transition state readily convert into this corresponding this transition state. So now you see, so if your substrate forms this transition state which readily produce Z-enolate ions. So this Z-enolate ion formation always favored by large X. So here you see large X and small L group. When you come to this transition state, so this transition state always forms the E-enolate ion which is favored by small x and large L group. So now you come to this our substrate. So this substrate having methyl group this side as well as this side having this substance. So now you think about if you have methyl group this side as well as L in place of L diisopropyl group, this system feels heavy 1,3 dioxyl interaction. That means that this particular our substrate forms this transition state. Since this transition state has minimal allelic 1,2 strain, which result that the generation of corresponding E-enolate ion. So this preferential formation of either Z or E-enolate ion we can tune by using mixed solvent system. So when you use mixed solvent system such as THF HMBA, which always favor to the formation of Z-enolate ion, since when you use HMBA, which strongly coordinate with this lithium cation, that breaking up the closed transition state, which leading to the formation of open transition state that resulting to produce this corresponding Z-enolate ion. So here you see in our question they provided only LDA, and most importantly most of the LDA based reaction people use THF is one of the common solvent system. Therefore, we consider here THF solvent. So now you come to the our substrate when you use LDA under THF condition, which readily produce corresponding E-enolate ion. After the formation of E-enolate ion, here you see next reaction condition is trimethyl silyl chloride. So when you use trimethyl silyl chloride, here you see this O negative charge readily attack the silicon atom, then followed by kick of Cl minus ion, which produce this corresponding silyl ketene acetal. So after the formation of silyl ketene acetal, when you heat the silyl ketene acetal, which readily undergo 3,3 sigmatropic rearrangement. So for this, you just start the numbering. So this oxygen will get number 1. So here number 2, here number 3. And similarly here also, you just put the number here number 1, here number 2, here number 3. And this position going to react by 3,3 sigmatropic rearrangement. Here you see how this happened. So this electron shifted here, then followed by this electron shifted this position, then followed by breaking of carbon oxygen bond, so which result that to produce corresponding alkene. So this particular 3,3 sigmatropic rearrangement undergoes by cyclic transition state. So here you see, so this portion having methyl, so here as well as here you see OTMS group, here also OTMS group. This OTMS as well as methyl both are present in the same direction. And when you come to the this alkene part, so here you see this methyl group as well as this CH2O group present in the opposite direction. So here you see, so this one present in the opposite direction. So in the way, this reaction undergoes by cyclic transition state to produce this corresponding gamma delta unsaturated carboxylic acid as a product. Here you should note the stereochemistry of two methyl groups. So here you see in this transition state, so this methyl group pointing down direction as well as at the same time this methyl group pointing upward direction. So based on that, here you see this methyl group pointing downwards and this methyl group pointing upwards. So in most importantly, this stereochemistry is relative stereochemistry, since here we have not used any chiral sources. So that means that this stereochemistry is relative stereochemistry rather than absolute stereochemistry. So this stereochemistry we can name as anti, since this both methyl group present in the opposite phases. Therefore, we can say that so this one is anti-product. Particularly, this reaction is 3,3 sigmatropic rearrangement. In specifically, this reaction is Ireland-Gleason rearrangement. Based on our analysis and considering the role of LDA in deprotonation and followed by the reaction with trimethyl silyl chloride, which generate corresponding silyl ketene acetal, which then readily undergoes by 3,3 sigmatropic rearrangement under heating reaction condition, which is called especially Ireland-Gleason rearrangement. So based on that, we can deduce that correct answer for this question is B. That's it for today's problem. If you enjoyed this video, please give it thumbs up and share it with your friends. And don't forget to subscribe and click the bell icon to stay updated with our latest videos. Leave a comment if you have any questions. And thanks for watching Chemistry 24/7 and bye bye.